Dear students, welcome to another math session. We will continue our topic of quadratic. Today we are going to look into the number of roots of a quadratic equation ax squared plus bx plus c. When we say roots, what does it mean? It simply means that values of x or solution set of the quadratic equation. Now, solutions, when we solve a quadratic equation, we can solve it using factorization, completing square form, and by using the quadratic formula. Here I have written down the quadratic formula. X is equal to minus b plus minus b square minus 4ac over 2a. And we know that just inserting the values of a, b, and c in the formula, we get the values of x, which are known as roots of this quadratic equation. Now, for a quadratic equation, there can be two values of x, there can be one value of x, there can be no value of x. How to determine that a quadratic or a given quadratic equation has how many roots without solving the equation? This is the task. So here in the next step you can see that I have written down discriminant. So discriminant, this is the part of quadratic formula underneath the square root. So this part, b square minus 4ac, b square minus 4ac is called discriminant of the quadratic formula. To know about the number of roots for a given quadratic function or a quadratic equation, we only need to focus on the discriminant, and then we need to check the sign of this discriminant. So the sign, it can be positive, it can be zero, or it can be negative. It means that when you solve discriminant using the values of b, a, and c, of course you will end up with a number, and this number may be positive, this number may be negative, this number might be zero. So whatever you get as your answer after solving the discriminant, so this sign of discriminant tells us the number of roots for a given quadratic function or equation. Okay, let's see how it works. So the rule is if the value of discriminant b square minus 4ac is greater than 0, it means if b square minus 4ac, the part which is under the square root, is greater than 0, mean if it is positive, then there are two distinct roots, right? So the equation will have two answers, two values of x, and if you try to draw the graph of such equation or such function, you may end up with something like that. The graph intersects the x-axis at two different points. So this is x1, say, and this is x2. Or you can have an inverted parabola like that, depending on the sign of a square in your quadratic function. But the graph must intersect at two different points on x-axis. So x will have two values. Similarly, if the discriminant is equal to 0, if the discriminant is equal to 0, then there are, we can say that, two equal roots. Now we use the term 2 because we are talking about quadratic. So quadratic equation normally has two factors, two values. So we are saying there are two equal roots, or basically it is one repeated root. And if we try to sketch the graph of such function, that function only touch the x-axis at a single point, either this way or this way, depending on the sign of coefficient of x square, as you know. So the graph will not intersect the curve at 2 points. It just touch the x-axis. The graph will not intersect the x-axis at 2 points. It will just touch the x-axis at a single point. And finally, if the discriminant b square minus 4ac is less than 0, means if it is negative, and you know that b square minus 4ac basically is under the square root, and if it is less than 0, you will end up with a negative number. So what is the square root of a negative number? It is not a real number. Okay, so there is no solution. There are no roots in such case, right? Because we cannot solve the square root of a negative number. We can say that no roots, or no real roots in general. No roots. We can just simply write it down. And in that case, if we sketch the graph of such function, it will not touch the x-axis. Okay, these are that anyway. Understand? So that is how you can use the discriminant of a given function in order to get the nature and number of roots. When I say nature of root means the roots we are talking about should be real. There is a concept of real number and imaginary number, which you will see in your A2 maths. At the moment, we are not going to discuss that, of course. But you can see that in your book, the word real is used. I didn't write it down, but here basically they said no real roots. And there are two equal real roots. Okay, and here also something like we can mention something like that. Okay, so that is the topic for today. So a very simple exercise is there, 2H. So work out questions from exercise 2H, please. Thank you.